Inaccurate system date time. Have you ever unplugged your computer to move it to a different room, and when you turned it back on, the clock on the desktop said it was January 1st, the year 2000? Or maybe you noticed that the time is constantly falling several hours behind no matter how many times you fix it. This symptom is known as an inaccurate system date and time. While it might just seem like a minor annoyance that makes you late for a meeting, in the context of troubleshooting motherboards, processors, and power for your CompTIA A+ Core 1 exam, it is a glaring red flag indicating a specific physical hardware failure. Think of it like a digital wristwatch. If you take the watch off your wrist and put it in a drawer, it does not forget what time it is because it has a tiny battery keeping the internal gears turning. Your computer motherboard operates on the exact same principle. To secure your perfect score of 900, you must understand exactly how the computer keeps time when it is completely disconnected from the wall outlet, and the cascade of critical system failures that occur when that mechanism breaks down. Let us take a deep dive into the technical architecture of the motherboard's memory and power retention. Deep inside the computer, there is a specialized microchip called the complementary metal oxide semiconductor, or CMOS. This chip contains a tiny amount of volatile memory that stores all the critical hardware settings for the basic input-output system or the unified extensible firmware interface. This includes the boot order of your storage drives, the speed of your random access memory, and the real-time clock. Because this memory is volatile, it requires a constant, uninterrupted trickle of electricity to keep its data alive. When the computer is plugged into the wall, the main power supply provides this trickle. However, when the computer is unplugged or experiences a power outage, the motherboard relies entirely on a small, silver coin cell battery to keep the clock ticking and the settings saved. This is almost always a CR2032 lithium battery. When this specific battery begins to die from old age, usually after 5 to 10 years, the voltage drops. The very first physical symptom of this dying battery is an inaccurate system date and time because the real-time clock simply does not have enough power to keep counting the seconds accurately. If the battery dies completely, the system develops total amnesia. Every single time you turn the computer off, the volatile memory gets wiped clean. When you press the power button again, the computer will halt the boot process and display an ominous black screen with a message like CMOS checksum error or system time not set, forcing you to press the F1 key to enter the setup menu. For the exam, you must understand that this hardware failure causes severe software consequences. Modern security protocols rely heavily on accurate timestamps. If the computer's internal clock thinks it is the year 2000, the operating system will look at the digital security certificates for secure websites and completely reject them because the dates do not match up. This means the user will not be able to browse the internet, download updates, or log into secure corporate networks, all because of a dead watch battery. In a professional troubleshooting scenario, if you encounter a machine with an inaccurate system date and time that also forgets its hard drive boot sequence, your immediate hardware fix is to power down the system. Use a small plastic pry tool to pop the dead CR2032 battery out of its socket on the motherboard, and snap a brand new battery into place, making sure the positive side with the engraved text is facing upward. After physically replacing the battery, you must manually enter the firmware setup menu one last time, input the correct date and time, and save the configuration. By mastering this relationship between the physical coin cell battery, the volatile memory chip, and the digital real-time clock, you will confidently breeze through this objective on your certification test.